Good morning. Welcome to my algebra class. We are working on Chapter 3, Section 5. We're working with equations again, and we're solving equations that have variables on both sides. We'll be using transformations to get the variable to one side and then solve. First example, we have 6x and 4x on opposite sides. Well, we could move the 6x over here, but then that would cause us two more steps. So the best thing always to do is get the variable on one side if possible immediately. So I'm going to move the 4x. So this is adding 4x, this is positive 4x, so I'm going to subtract 4x from both sides. So that leaves me 2x equals 18. And then divide by 2, and my solution is 9. And you can plug it back in and check it. 54 equals 36 plus 18. If you do it the other way, I'm just going to show this once. It works. However, it takes a number of steps, and most people make a mistake when they do this. If you subtract 6x from both sides, you get 0 equals negative 2x plus 18. Then you have to subtract 18 from both sides, and you get negative 18 equals negative 2x. And then divide by negative 2, and you still get 9 equals x. However, we had an extra step thrown in here, whereas we did this in 2 steps. This took 1, 2, 3. So my advice is, and I'd like to see you do this, is that you get the variable on one side immediately if possible. Here again, I have the 3y by itself over here, nothing with it, so I want to move the 2y over here, and it's a negative 2y. So I'm going to add 2y. That eliminates it on this side, and I have 5y equals 15. Divide by 5, and I have y equals 3. The next example is a two-step problem, but it has an x on the other side, and instead of subtracting 4/5 x from both sides, I'm going to eliminate the fraction by multiplying by the denominator 5. So we can get rid of the fraction, because 5 times 4/5 x, the 5 will cancel out, leaving me 4x. And now don't forget to multiply the 3 by the 5. That's the distributive property. So we get 15 equals 5x. The 5x is by itself, so we want to move the 4x to the other side. So the opposite of adding 4x is subtracting 4x. So we get 15 equals x. And we're done. Problem number, or example number should be 4, but it's marked 5. We want to eliminate the fraction again, so we're going to multiply both sides by 9 to eliminate the denominator, so the 9's cancel out. And that leaves us 8 plus x equals 9x. And the reason you don't multiply the x by 9 is because the 9 was underneath the entire numerator, whereas over here it was only underneath the 4. So the 9x is by itself. So we're going to subtract x from both sides to get the x's on one side. And we get 8 equals 8x. Divide by 8, and x equals 1. Problem number 6, or example 6, get rid of the parentheses, so we have 5x plus 10 equals 5x plus 18. Trying to get the x's on one side, we would subtract 5x, and what happens is the variable is eliminated and we get 10 equals 18. So once I get numbers without any variables, I can tell if the statement is true or false. In this case, it's false. So no matter what number you put in for the variable x, there's nothing that will work, so there's no solution. In the last example, we first want to get rid of parentheses, use the distributive property. So we have 4a minus 12 minus 9 equals, and we can collect like terms right now here, that's 4a, 3a plus a, minus 21. Over here, if we collect the numbers, it's a negative 12 and a negative 9. We get 4a minus 21 equals 4a minus 21. Subtract out the 4a, so trying to get the variable on one side. And what happens is we're left with negative 21 equals negative 21, which is a true statement. It's an identity, and that means all the real numbers work. And you can indicate that with the script R. You need to get your paper for the video evens. So heading on your paper, skip a line, page 118, written 1 to 30. Problem number 2. Copy it down, 8a equals 2a plus 30, and the directions say solve each equation. If the equation is an identity or if it has no solution, write identity or no solution. I'm also going to put in the script R. Since 8a is by itself and nothing else is with it, I'm going to move the 2a. So subtract 2a from both sides. And we get 6a equals 30. Multiplying by 6, divide by 6, and we get a equals 5. Remember, you can always check your answers by plugging them back in. 5 times 8 is 40. 2 times 5 is 10, plus 30 makes 40. Problem number 4. 2b equals 80 minus 8b. Again, the 2b is by itself, so we want to move the 8b, negative 8b over there, so the opposite of minus 8b is plus 8b. That gives us 10b equals 80. Divide both sides by 10, and we have b solved. It is 8. Problem number 6, copy it down, it's 3x equals 27 minus 15x. Please be sure that you're using one line of work for one line of the paper. 3x is by itself, so we're going to get rid of the minus 15x on the right by adding 15x. So it gives us 18x equals 27. Divide by 18 to get the x by itself. And we get x equals, simplify the fraction, 9 goes into 27, 3, and into 18, 2. And leave your answer in fraction form. Problem number 8, 51 equals 9 minus 3x. Since there's only one term with an x, we just start in the two-step process. Undo the adding 9 by subtracting 9. So we have 42 equals negative 3x. Divide both sides by negative 3. And we've solved for x, it's negative 14. Problem number 10, 39c plus 78 equals 33c. The 33c is by itself, so we want to move the 39c out of the left. The opposite of adding 39c is subtracting 39c. So we get 78 equals 33 and a negative 39 is negative 6c. Solving for c, divide both sides by negative 6. And we have c equals negative 13. Problem number 12, negative 7a equals negative 12a minus 65. Again, the negative 7a is by itself. So we want to do the opposite of negative 12a and get that out of the right. So we're going to add 12a to both sides. And that's negative 7 and 12 make positive 5a equals negative 65. Solving for a, divide both sides by 5, and we get a equals negative 13. Problem 14, we have 5p minus 9 equals 2p plus 12. When you have variables on both sides with another term, usually the best thing to do is keep the term with the variable positive. So I'm going to subtract the 2p from both sides. So we have 3p minus 9 equals 12. We want to get rid of the minus 9, so we'll do its opposite, add 9. So we have 3p equals 21. And then solving for p, divide by 3, p equals 7. By keeping the variable positive, I don't end up with the opposite of a variable, so I have an extra step if I end up doing that. 16, we have 89 plus x equals 2 minus 2x. Variables are on both sides. If I want to keep the variable positive, then I would add 2x to both sides. So now I have 89 plus 3x equals 2. Subtracting 89 from both sides to solve for x. 2 and a negative 89 would be negative 87. So we have 3x equals negative 87. Dividing by 3, x equals negative 29. Problem 18, 5n plus 1 equals 5n minus 1. Trying to get the n's on one side, we end up subtracting 5n from both sides, and we get 1 equals negative 1, which is a false statement, so no solution. In problem 20, we have 4 times the quantity y minus 6 equals 7y. We have to eliminate the parentheses, simplify, so won't use the distributive property. We get 4y minus 24 equals 7y. The 7y is by itself, so we want to move the 4y off the left. So do the opposite, subtract 4y. We get negative 24 equals 3y. Divide by 3. And we get negative 8 equals y. Problem 22, 7 times the quantity 2 minus m equals 3m. Simplify, get rid of the parentheses. 7 times 2 is 14. 7 times the negative n is negative 7m. 3m is by itself, so I'm going to add the opposite of negative 7m to both sides. So I have 14 equals 10m. Divide by 10. Simplify the fraction. 2 goes into 14, 7, and a 10, 5. So my answer is 7/5. Problem number 24, I have 2/3 x minus 7 equals x. I have variables on both sides, but I want to get rid of that fraction, so I want to multiply by 3. The 3's cancel, leaving me 2x. And I also have to multiply by the distributive property, the negative 7, so I get minus 21. 3 times negative 7 is negative 21 equals 3x. Okay, now I have the 3x by itself, no fraction, so I'm going to move the 2x by adding its opposite. So I get negative 21 equals x. I have x minus 2 over 3 equals x. I want to eliminate the fraction, so I'm going to multiply both sides by 3. This case is different than the last one since x minus 2 is completely divided by the 3. When I cancel the 3's out, I'm only left with x minus 2 equals 3x. Since the 3x is by itself, I want to do the opposite of x on this side and move it out of here. So subtract x from both sides. I get negative 2 equals 2x. Solving for x, divide both sides by 2. Negative 1 is my solution. Problem 28, you have 6 minus 4y over 2 equals y. Again, I need to get rid of the fraction, so I'm going to multiply both sides by 2. The denominators cancel, the numerator and denominator cancel. I have 6 minus 4y equals 2y. The 2y is by itself on the right, so I'm going to eliminate the negative 4y on the left by adding 4y. So I have 6 equals 6y, divide by 6, and I've solved for y, which is 1. And the last problem, 23 minus 11c over 7 equals 5c. Again, eliminate the fraction by multiplying by the denominator. So the 7's cancel out, leaving 23 minus 11c equals 35c. 35c is by itself on the right, so I want to eliminate the negative 11c on the left by adding 11c. That gives me 23 equals 46c. Divide by 46, and 23 is a half of 46, so it's 1/2. That concludes the evens. Be very careful that you check your answers as you do each of the odds. Get help as needed.